You can super generalize and split out two scenarios. One where you are using MIDI engine on EC2, in this case Graviton, for transcoding, which is a very popular way. Here in Playtech, we never transcode. We always encode from source all the necessary qualities, but we do use that as a transmixer and a packetizer, whatever is needed per case, per protocol, what we deliver. We normally scale out on cloud, not because of CPU, which, well, now we can set at 90% and sleep on it, but we normally scale out with the network out being the trigger. So in other words, this instance is reaching the network out capacities available per instance size. With Graviton behind it, you generally will have more network bandwidth available. You will have, I don't know, in my experience, up to 20% more bandwidth available for the same size of the instance compared to Intel or AMD ones, or x86 in short. So from that perspective, this allows us to literally have less instances running because that one instance is simply maxed out significantly more.
Yeah, which obviously helps you out a lot with costs. The fewer instances, the more streams per instance, the better off.
From the cost perspective, this is a good point, because it's not just the way how those instances are listed at cheaper rates than the x86 ones. It's as well those bits and pieces. The devil is in the details. So you can push that CPU, you can put out network. These have very, very generous bandwidths, both for x86 and ARM. But for ARM, it has more generous. Sweet spot for us is just the compute generation without the network, from our experience. But we are really maxing that network out there.
Let's go ahead and look at some benchmarks we have done. And I'll have a couple caveats here, but let's first look at, this is CPU encoding on a Graviton instance. We have a variety of different streams, and then we have 3 different Graviton instances. The source stream is either a 60 FPS, a 30 FPS, or a 24 FPS 1080p stream. What we have is the characteristics of the machines here as far as virtual CPUs and memory. And then we have the number of streams we ingested. And what we've typically done here is created a 3-rung ABR ladder out. And what you'll see here is you'll see how hard we were able to drive this particular machine until it couldn't keep up, right? So in streaming engine parlance, that means we'd start to see skip frame messages and things like that, indicating that if we add more streams to the transcoder, it's going to start to get jittery and the output won't be good. Particularly impressive is the Graviton 4, which is that CAG24XL, super high performance there, right? On a 60 FPS 1080p stream, we're able to do 22 inputs and 66 encodes, which is huge. If you have transcoder intensive workloads, there's an awful lot of the bang for your buck here. For comparison, the caveat here is these are C5s. Now, while C5s are pretty much available everywhere, it is a C5 versus a C8. So you may get 15-20% higher performance on that C8 versus what you'll see here. You can certainly try it. You can go to our benchmark page and we'll give you all the information, including the sample files and the templates to go try it yourself. Even on a C5 24XL, which is the Graviton 4 equivalent, far fewer streams, less than half at a 1080p 60. So you're really seeing the benefits of a Graviton here, both just on stream density, cost efficiency, as well as energy efficiency. So these Graviton instances are really well optimized for video, given if you're using software that can take advantage of it.
This is really what I always want customers to do, is just to try out Graviton. We've started just comparing Graviton generations across each other and stopped even comparing them to x86. We rely on customers and partners to take that lens. But we've continued to see generation over generation improvements in Graviton, and I think that's one of the things that customers really appreciate when they start to try it. I always enjoy the story when customers start to try it out and see that it works better, and costs less. That's always a pretty happy story to tell. I know these are quite compute intensive tasks that you're doing here, so it's nice to see Graviton keeping up well there.